In the brutal winters of World War I, British soldiers weren't just dying from enemy fire. They were freezing to death in collapsing tents, soaked by snow and rain without proper shelter. Makeshift barracks failed, supply chains were stretched, wood was scarce, carpenters were on the front lines with rifles instead of hammers. And through this chaos, one man asked a very simple question. What is the fastest possible way to build shelter with what we already have? His name was Lieutenant Colonel Peter Nissen, a Canadian-born mining engineer serving in the Royal Engineers. Nissen wasn't an architect, and he didn't have time for blueprints or perfection. What he had was a battlefield covered in dying men and piles of corrugated steel sheets left unused near supply depots. These were originally roofing material, discarded because no one knew what to do with them. But Nissen saw potential. Rather than try to build traditional structures, he imagined something entirely different. Take those curved panels, bend them into a half-cylinder, and bolt them together. No posts, no beams, no concrete, just arched steel forming its own shell, directly on the ground. In March 1916, Nissen tested this idea. With just 6 untrained soldiers and basic tools, they erected the first Nissen Hut in under 4 hours. It was genius in its simplicity. The walls and roof were the same material. The structure required no internal frame. The sheets were pre-drilled, the wooden ends prefabricated. A hut could be built almost anywhere, on dirt, on wooden sleepers, or over rubble. By the time the first prototypes were approved, the British Army placed an urgent order for 10,000 units to be shipped to the front before the winter of 1916. Within months, Nissen huts were everywhere. Across France, Belgium, the Middle East, even Africa, these curved steel shells became barracks, supply depots, command centers, and field hospitals. They were cheap, fast, and easy to build. And most importantly, they worked. Each hut could house 30 soldiers with bunks or 50 in emergency conditions. During the Battle of the Somme, construction teams were erecting them under active artillery fire to shelter the wounded within hours of being evacuated. By the end of World War I, over 100,000 Nissen huts had been deployed. They represented a complete rethinking of military construction. Traditional barracks required carpenters, masons, concrete, and weeks of effort. The Nissen needed none of it. With no foundation, no framing, and no specialized labor, a team of infantrymen could build a life-saving shelter in 3 days. But while the British Army was solving problems with speed and minimalism, the United States was watching. As war loomed again in the late 1930s, American military planners knew they would soon need fast, scalable shelter. In 1940, Navy Commander George F. Dorrit was sent to England to study British temporary construction methods. What he found was clear. The Nissen Hut was the fastest field structure ever created. But the Navy didn't want fast alone. They wanted better. So when America entered World War II after Pearl Harbor, the U.S. Navy adapted Nissen's idea, but with significant changes. At Quonset Point Naval Air Station in Rhode Island, engineers began developing a new version, the Quonset Hut. At a glance, it looked similar, an arched steel structure with corrugated panels. But the approach was entirely different. Where Nissen's hut used the metal panels as both the skin and the structure, the Quonset introduced an internal steel frame, curved ribs that stood on their own, to which panels were simply attached, like cladding. This internal framework allowed for more stability, especially for long-term use. American engineers also added fiberglass insulation, plywood interiors, built-in electrical conduits, and wooden floors. These enhancements made the Quonset Hut more comfortable and permanent, suitable for not just housing troops, but also serving as classrooms, workshops, offices, and even post-war homes. But this came at a cost: complexity. A standard 40-foot Quonset Hut needed over 700 bolts and screws compared to just 200 in a Nissen. The ribs had to be perfectly aligned. If one part was damaged or misaligned, the whole build slowed or stopped. On uneven terrain like sand or mud, Quonset construction was often delayed for days just trying to level the frame. In North Africa, British engineers built 16 Nissen huts in 9 days using local laborers who spoke minimal English. American engineers in the same theater struggled to erect Quonsets because the steel ribs warped in desert heat and twisted on soft ground. Windstorms even knocked over half-built frames. The Nissen huts, by contrast, were already standing, bolted directly to railway sleepers and braced with sand berms. During the Pacific Campaign, the heat and humidity made Quonset construction even more difficult. The steel was too hot to touch by midday. Fiberglass insulation soaked with sweat and moisture became a breeding ground for mold. In contrast, Nissen huts, without insulation but with natural ventilation through the corrugated gaps, stayed relatively dry. So why did the U.S. stick with the Quonset? Because back home, the improvements mattered. After the war, the U.S. government found itself with tens of thousands of surplus Quonset huts. They were sold to civilians for $200 to $600 each and quickly became homes, garages, storage buildings, and even schools. Some Quonsets are still in use today, 75 years later, because they were built to last. In fact, in the post-war years, Quonset huts became a cultural icon. They symbolized not just wartime production, but American ingenuity and industrial dominance. Airports, universities, and farming communities repurposed them in creative ways, while many military bases used them for decades. The Nissen, by contrast, was not built to last. It was built to arrive fast, serve its purpose, and be abandoned. After the war, the British government tore most of them down. Some were converted to barns or workshops in rural areas, but many simply disappeared. Nissen huts weren't designed to impress. They were designed to survive. That's the true difference between the two. The Quonset was better, no doubt. It was insulated, durable, functional, and standardized. But the Nissen was faster, and on a battlefield, faster wins. Both designs had their place. The Quonset became a post-war icon. The Nissen became a symbol of wartime necessity. But in combat conditions, when soldiers were freezing in the trenches or wounded in the mud, there was nothing more valuable than shelter that could go up in a day, with no foundation, no crane, and no electricity. Peter Nissen's creation ignored architectural tradition. It didn't care about beauty, longevity, or engineering theory. It answered only one question: how fast can we get our men out of the mud and under a roof? And the answer was brilliant in its brutality: curved metal, a wrench, and a team of exhausted soldiers. It also reminds us of something much larger. In crisis, the best solution isn't always the most sophisticated, it's the one that works right now. In military terms, that could mean the difference between life and death. In civilian terms, it's a powerful metaphor for design, engineering, and problem-solving at large. Modern military shelters are now containerized, pre-wired, and air-conditioned. They cost tens of thousands of dollars, but they also take days to deploy and require special transport. What Nissen achieved with sheets of steel and 6 men under artillery fire has still not been fully surpassed in terms of speed to shelter. That's not just a footnote in history.